Hi, thanks for joining the course. So let's talk about the data science hype. What exactly is data science? Is it artificial intelligence? Is it big data, machine learning, analytics, predictive intelligence? These are all buzzwords you would have heard from people in media, people in different fields. Everyone is talking about it, but what exactly is data science and what is a data scientist? Is a data scientist someone, who solves all our problems magically with some computer whiz and programming and statistical knowledge? Or should we be wary of data scientists? Should we be careful of what they know? But before we go into that, that's a moral dilemma. Let's talk about data science. What exactly is data science and why should you care? I mean, obviously you care because you've started this course and you want to learn more and you want to learn how to apply data science to your business or to any business or real life cases. But let's take a look at data science to be a little bit more specific. Let's think about it. Making sense of data. However, that doesn't tell you much because a lot of you who are beginners right now won't exactly know what even data is. In fact, a lot of people don't understand what data is. They think it's a spreadsheet, and data can actually be anything. It can be images, videos. It can be hard copies of legal documents for the last 100 years. That is all data. But think about it. I just used that example of legal documents. Let's think about land deeds for a city that has like 100,000 people over the last 100 years. That is a lot of data. There's a lot of things going on there. And how do you make sense of it? How do you pick up trends? How do you infer when was a good time to buy? How were prices varying? What family was basically buying up a lot of land? These are all things that can be revealed by data. So when I say making sense of data, that is kind of what I mean. Also, data science includes something called predicting outcomes. Now, that should be self-explanatory. However, this is probably the hardest part of data science and the part that everyone is most curious about. How do you predict things from data? And then another big portion of data science is uncovering and discovering patterns. Pattern recognition in data is vital because in that same example with the land deeds, you want to figure out patterns over time. Maybe you can figure out things that cause a crash or a economic boom just by looking at land transaction data over the last few hundred years. And then most importantly, creating intelligence out of data. Now that sounds a bit generic, but when I say creating intelligence out of data, it pretty much means you have all this data. How do we get things out of it? How do we learn from it? How do we build models that can predict different things? How do we do all of this? These are all generic things, but this is what data can tell us, essentially. And now let's talk about the data science demand, because even right now, even with COVID-19, as you can see in my next slide right here, there has been no let up in demand and hiring for data scientists right now. Because as soon as a company that has been severely affected by COVID, like let's think of Uber or Airbnb, lay off their data scientists, they just get swooped up right now in different industries. Because at this point in time, especially when people are trying to fine tune and make their business more efficient, data scientists are key to that. And as you can see from the projects on this course, there are just so many areas data scientists can apply themselves in the business world to improve things. You're talking about things like predicting which customers will convert faster, how to improve our marketing, how can we segment our customers to find our best or most profitable customers and get them back. Recommendation systems as well. How do we recommend products or items or services that certain customers will like the most and will be most inclined to buy? So these are the questions and problems that data scientists are solving right now in the business world. And that is why you can see they're in such demand. And those are just generic, simple projects. There are actually a lot more others that data scientists can apply themselves to and help streamline businesses. And like I said, COVID-19 has certainly not diminished the demand for data scientists, at least not in my experience. In my city of London, I'm getting job request interviews constantly. And I'm not even like a super good data scientist. I'm just like fairly experienced now. But everyone is getting a lot of requests still right now that I know of. And so hiring is definitely continuing. But there's a problem in data science, and that is data science is hard. It's a multidisciplinary field that involves several things, as you can see here. If you want, you can pause this slide and take a look at this. Now, I will tell you though, Not everything here is essential for a data scientist right now to function. Right now, you just need to have programming, statistical knowledge, maybe some database basics, machine learning, just on this high-level understanding of the core algorithms, definitely visualization skills, but and definitely you need data munching and data wrangling skills. But things like data ingestion, these toolbox things, NLP, those aren't critically essential. Even big data isn't critically essential right now, but it's always good to know. And the biggest problem in data science, at least to me right now, is that things are changing so fast. It's such a fast-paced, evolving field that things can be the hot tool right now, and then 2 weeks later, there's this brand new module or library that's taking over the data science world by storm. So you have to get used to this. You have to understand it's a fast-paced field, but once you know the basics, which is what I'll be teaching you in this course, you will be fine. You'll always be needing those core basics, and then everything else is just icing on the cake. You'll just be using that easily. So when you get a new tool, it's not going to be that difficult for you to get used to once you understand the core tools that I'll teach you in this course. Right, so I don't want this to be you. I want to actually show you all the basics so that you don't have to be just jumping in, using different tools and having no idea what you're doing, because that's how the data science world is right now. There are tons of these micro tutorials you find on YouTube or on blogs that show you quickly like a snippet of what you need to know, but you don't understand the foundation of what you're doing. And that's what I'm going to try to help you with. So what you're going to be getting in this course is you're going to understand all the basics that a data scientist needs to know. You're going to understand the secret power of data and actually how to unravel it and basically have data make sense to you and just uncover all these secret things that were hidden in the data. And what is equally important is understanding how to use the knowledge you get in the data to solve real-world business problems. So let's take a look at our learning path. We're getting a basic introduction into Python. Then you'll touch on data wrangling using pandas and NumPy. Next, we take a look at the visualization libraries such as Matplotlib and all the popular ones as well to create some very cool and fancy visualizations. Then we'll take a look at statistics, probability, and hypothesis testing. Then we do some dashboard design using Google Data Studio. And then we take a look at all the important machine learning algorithms such as linear regressions, logistics, SVMs, naive Bayes, random forest, and a couple others. Then we take a look at deep learning, and deep learning is actually pretty important right now. It can technically solve almost any machine learning problem right now. And then we start doing unsupervised learning, where we look at clusters and segmentation, and then take a look at recommendation systems. Then we take a look at using big data libraries such as PySpark to get a handle and feel of how we treat with big or very large data sets that can't fit on your memory on your local computer. And then we take a look at deploying machine learning models on cloud services. So we're going to deploy one on Heroku as a project in this course. So in this course, what you'll be learning is basically software development, just some introduction to Python. You're going to learn the maths and statistics of machine learning at a high level. Then you're going to start looking at the business domain knowledge for a lot of different problems I'll expose you to. And that would basically make you a fairly decent data scientist that if you do everything in this course and understand that, say, even at 70%, you're definitely a hireable person right now. I'm a co-founder in 2 startups right now that have been yet to launch, and I would definitely consider hiring someone who has that knowledge as a junior data scientist. And finally, you don't have to have any real set of requirements to take part in this course. This course is targeted to beginners, and these are the requirements for the course. I assume you're a total beginner, so you don't have to have any prior knowledge joining in this course. However, some familiarity with programming and maybe high school level math would definitely be beneficial, because I'm not going to teach over those concepts, but especially with the programming, a lot of the basics I teach, so you don't have to fear that. So if you have a fear of programming, don't let that hinder you in this course. I'll definitely explain all of these things to you. Also, it would be good if you had some familiarity with statistics and data science, but definitely you don't need to know anything. The best thing you need right now is just enthusiasm, interest, and passion for working with data, which is what we'll be doing in this course. So thanks for joining. So I've carefully selected a lot of different case studies to teach you guys. So let's take a look at the categories or the sections I've broken them up into. Firstly, we have data analytics and statistical analysis or exploratory type projects. We have the predictive modeling and classifiers. Those are simple machine learning type projects. We have data science and marketing, which encompasses exploratory and machine learning projects. So there's this. However, this is more geared toward clustering and recommendation systems, as well as product and customer analytics. Then we take a look at time series forecasting, natural language processing projects, big data projects. However, these are quite simple right now. And then take a look at deployment or deploying our models into production. So let's take a look at the data analysis and statistical or exploratory projects we'll be doing in this course. So the one I had a lot of fun doing was the US 2020 election simulation using over 1,800 different polls that were gathered from the 538 database. That was a pretty cool project, and you can take a look and see if we got it right. Then we predict diabetes cases from health data. We do a market basket analysis. We predict the FIFA World Cup based on past data. We do a COVID data analysis project and then create a very cool flourish bar chart visualization. Then we take a look at the Olympic data to determine who are the best Olympians of all time. And then we take a look and see if there's a home advantage in soccer or basketball. It's quite fun project as well. Afterward, we take a look at some cricket data. So you don't have to be a fan of cricket to appreciate this project because this can apply to any sport. We also take a look at streaming services, the movies on them, and do some nice comparisons. Look up the IMDb ratings, see which streaming service is the best, at least for movies. Then we take a look at some pizza restaurant analytics, determine what's the most popular pizza across the US. We do a similar thing for pubs in the US as well. Then we take a look at some simple supply chain data sets. We could do an Indian election comparison, which can apply to any country as well. And then we take a look at some economic data from African countries. Afterward, this is where the business projects start coming up more. We do some classical business projects, machine learning projects, things like finding out which employees may quit or which customers may leave. We look at things like who do we target for donations if we have like a charity type group, using our data to figure out how we can do better or more targeted canvassing for advertising. Then we take a look at how to predict insurance premiums, Airbnb prices, detecting credit card fraud. And next we take a look at our marketing projects where we analyze conversion rates for different marketing campaigns, predict the engagement our new ads will drive, how do we compare ads fairly using A/B testing, and then figuring out who our best customers are and determining their customer lifetime values. Next, we take a look at retail, and these are quite fun too as well. We take a look at some product analytics to explore which products are doing well, most profitable, give general statistics like that, something that like a regional manager would love to have. Afterward, we take a look at customer clustering, which is quite important, and this is one of the best projects I think on the course, as well as product recommendation engines, which I love building as well. We actually have a fifth one here that I haven't included in this slide. That is using deep learning to do movie recommendation as well. That's based on a different movie data set. This deep learning data set is actually a Wikipedia scraped movie data set, so it's quite cool. Then we take a look at time series forecasting to predict demand and sales, or to how to trade stocks using reinforcement learning, or how to predict oil prices as well. And next we take a look at natural language processing projects where we do a sentiment analysis on tweets, and those tweets are from airline data in the US airlines, so people tweeting about American Airlines or Southwest Airlines. We just analyze all of them and determine which airline has the most negative or positive feedback based on tweets. And then we just start with a simple spam filter so you can actually start seeing how we build NLP classifiers so that you can use them in your workplace. Next, we take a look at big data projects as well. Now, the first project we do is a simple analytics project with a Titanic passenger data set. Then after we go on to a cooler one, which is newspaper headline classification. And this is all using PySpark. And then lastly, we take a look at how do we deploy our machine learning model into production. So this is actually a working deployed model I have right here. So you enter some text here and it predicts the category that text belongs to. You get to build a model and deploy it on your own. So you yourself will have your own little showcase machine learning portfolio on the web for free, by the way. Hi, and welcome to the chapter Why Data is the New Oil and What Most Businesses Are Doing Wrong. So now, has this ever happened to you? You're thinking about a product, or you're thinking about starting a course, or you're just mentioning something, a place you want to visit to a friend, and then suddenly you're on your mobile phone and you're getting ads for that exact thing that crossed your mind. Now that's spooky. You're probably wondering what sort of black magic or mind-reading device does Facebook or Google have? When the truth is, it's not magic. It's our data they're using. And they're using this data for many reasons, but the most important thing they're doing with our data is basically they're trying to sell us more appropriate ads. And why is this important? So just think about the business model of Facebook, for instance. Facebook is becoming a marketing advertising forum or medium. And they want to basically compete with billboards, radio, TV. So they have to figure out a way to make their ads the best value for money for people seeking to buy ads. So let's assume you're a developer for a game company, okay? And you have a new game that you want to market. And basically you were thinking about billboards and all these different things. Now billboards can reach a wide audience. However, that's going to make it more expensive. Whereas if you can get exactly targeted niche ads on Facebook or on Google, suppose it's a very odd niche strategy World War II game that isn't even going to appeal to the wide cross-section of gamers. You're going to want to know which gamers like these types of difficult niche games and target them with ads. And that's the value Facebook or Google seeks to give advertisers. The ability to do very, very targeted ads at a very cost-effective rate is brilliant, and it is paying off for them in the billions right now. And it's not just Facebook or Google who are taking big advantage of data. Think of a company like Uber. Now, I once had a friend who told me he doesn't see Uber as a data science or machine learning company. He thought they're basically just a service company to find taxis, and that's all they do. And I basically had to argue him down, telling him that there are tons of data science and machine learning stuff going on at Uber. And I had to explain to him, it was things like estimating driver arrival times, or estimating fares, or optimizing surge prices when demand was high, or optimizing driver positions by creating heat maps so drivers know where to position themselves in the city. These are just some simple examples how Uber can be using data science internally. However, I'm sure there are tons more that we can't even think of right now. And the companies like Netflix. Now, I mentioned recommendation systems earlier on in the previous chapter. However, Netflix has solved such a big problem here with recommendation systems. They have a library of probably like hundreds of thousands of movies and TV shows on Netflix. How do they know what to recommend to you? They have a very complicated system that's based on genres of shows, similar shows you've watched, how similar your watching habits are to someone. So all of this goes into their algorithms to predict things that you would like. So it helps your selection process. So it optimizes your selection process significantly. And what about traditional businesses? Think of banks. Banks are now harnessing their data to determine things like whether to give customers loans or who can qualify for more credit, or even simple things like predicting cash flow or optimizing interest rates or who might file for bankruptcy. These are things that our banks are now beginning to do and catching up into the data stream right now. So right now, we're calling this era the ubiquity of data opportunities, because this means there are just so many applications for data science right now. Things like automated recruitment of employees, predicting cryptocurrency prices, forex or stock prices. There are just tons and tons of things in health alone. Things like disease prediction, finding cures, predicting whether these types of accidents or diseases are going to happen more or another, so we can stockpile different medications. Things like computer vision, which have been enhanced greatly by deep learning, is enabling things like self-driving cars, facial recognition, stores with no employees, like the Amazon store in Seattle. These are things that are just now coming on stream right now. In the agricultural and farming divisions, there's just so much data to collect, so you can optimize, optimize different processes. Same goes for the manufacturing sector. Even things like creating art and music, self-driving cars and robotics, chatbots through NLP. There are just so many applications of data science right now and deep learning. So there's no shortage right now of what we can do with it. It's basically coming down to your imagination. Finding a problem, do we have data to support this or learn from it, and building a solution using AI that can solve it. So what exactly are most businesses doing wrong right now? Well, believe it or not, there are businesses that actually aren't even recording their data. They have no proper logs. These things are just being dumped in different temporary folders. There's no backups going on, so it's just a mess. And it's because they don't see the value in this data. So, and then there are companies that are recording their data, but they aren't doing anything substantial with it. They're just discarding it because basically storage costs are just going up and up. And also, a lot of companies think they're doing data science. However, they're mistaken things like simple business analytic reports as a substitute for data science, which it's not. It's a good start. However, it's not nearly as powerful as what you can do with deeper data science techniques. And there's a problem here where a lot of people don't trust the data and they rely on their intuition instead, saying things like, I don't trust that machine, or I don't trust any AI to make my life easier. That's sort of a backward point of view. However, it's not always bad, because sometimes relying on data can basically make you biased or statistically flawed. You have to understand the weaknesses in your data to actually use it effectively. So basically, this is why data is the new oil. Data provides so much value and so much power to businesses, leading to better decisions and more profits, which is the key bottom line that shareholders want to achieve. So thank you, and let's move on to the next lesson. Okay, so before we move on, I'm going to talk about a bit about data analytic thinking and making data-driven decisions and how we define business problems. So what exactly is analytical thinking? Analytical thinking is the ability to identify and define problems, extract key information from the data, and develop a workable solution for the problems identified in order to test and verify the cause of the problem and develop solutions to resolve the problems identified. Now, this seems like a bit of a mouthful, and I admit it is, but look at the keywords here. To be analytical thinking, to adopt that mindset, basically we have to look at a problem. Just think of any business problem you can find of, like maybe sales are dropping in a particular store in a certain region. So that's the problem. We identify the problem and we extract key information from the data just to basically identify and be more granular to figure out what is happening in that area. And now we take that data, the analysis of it, develop a solution for the problem identified, and then we have to test and verify that this is the cause of the problem. And maybe we have to try this a couple times to see what actually works in the end, because this means we're going to develop a solution to resolve the problem here. So that's basically what it is. And let's look at data analytical thinking. So for businesses who utilize data analysis and data-driven decision-making is critical. It's so critical that it can almost blind them sometimes, but just remember, it is critical. So before you go ahead solving and attempting to look at data, you basically have to have a deep understanding of the business problem. And that is the domain, basically like suppose you're trying to solve a problem in the insurance domain, and you basically don't understand like why people buy insurances or what this type of insurance is for. So you're going to be making wrong assumptions maybe right from the get-go, and that's not good. And also you need to know how this data is generated. Like, for example, imagine you built a model, all right, that was 97% accurate in this disease detection. It's pretty good, right? Perhaps, but suppose it missed 3% of the patients who actually had it. So now you're testing, let's say you're testing for Ebola, and 3% of the patients who had Ebola, our test didn't pick it up. Think about it. People who have Ebola are not being detected, even though our 3% of those people, even though our test is 97% accurate. That is not good at all. Okay? So it's quite preferable to have a model that is less accurate, 90% accurate, but it never failed to detect the disease. So basically it means the test was super sensitive, which means that it's probably going to, the people who don't have Ebola, it's probably going to identify some of them having Ebola, which it may scare them, to be honest, and may get put on the quarantine, blah, blah, blah. But you know what? It's better we actually quarantine those people rather than have 3% of people who had Ebola go back into the general population and spread that disease. So while I admit, by the way, this doesn't relate to where I was going with this, how the data is generated, it is an example of basically in how you think about business problems, like the solution to it. Like, is this what we want, or is this what we want, or is this what we want? Or how do we find a balance that satisfies all parties? So it's important to know when you're thinking with data that you tend to have to actually use the data wisely in a way that you actually solve the problem at hand. So exactly, many times companies can hire the best data scientists who are technical geniuses. They can create elaborate models, super accurate, all those things. However, they can miss the big picture and probably lead to some... It happened to me a couple times where I spent like days doing analysis only to come up with something that was quite obvious to everyone else. But at least I had data to prove it. So some key points here. Data should be improving the decision making, not misleading or adding to the confusion. A great data scientist needs to understand the business domain you're working in, the goal of the model, that is, what is the problem they're solving, the statistical weaknesses of their model, like we go back to that Ebola detector, where we can actually tell someone you're going to learn all this in the course, by the way, how to assess your models, but we need to know what is the weaknesses of their work and how it can be improved, or if it can be improved. And this one is of utmost importance, how to communicate your findings effectively. Like, I've had trouble with this, to be fair. I think everyone has at some point, where you come up with this fancy presentation, all these graphs and stuff, and you present it and everyone is confused. And you end up spending like a half hour, or maybe longer, just trying to explain your results to people who are becoming increasingly skeptical because you're there bumbling around trying to explain stuff and no one is listening. So if you have something key to show, bring it up first. Show the key findings first. Then you drill down deeper and deeper in how you got this. So allow them to ask questions, allow them to understand, ask questions, and then you verify and back up your stuff. Okay, so up to this point, we've talked a lot about some examples and things you can do with data and how to think about data. So now let's just go through some quick examples so you can understand quickly, because I realize a lot of beginners sometimes have trouble understanding like how they can apply their data science to businesses. So let's get this done quickly and we'll move on. So just remember, data is growing all around you. From your customers' data to the industry data. We live in an age where there's no such thing as no data. There's just literally so much data being collected and stored everywhere. And data is produced not only by our own business systems, but external data as well. You have social media, you have Google Trends, all this stuff being collected. So data is being collected with every click right now. So what do we do with this data and how do we add value to businesses or our business? So let's look at 10 projects that we can actually apply data science to. And basically the scope of these projects are some analytics projects. So analytics does fall under data science. All data scientists should be good data analysts as well. It's not a prerequisite or requirement, I would say, but it's a very good thing to have. And I'll talk a bit about analytics further on, or what a data analyst does. So these are the projects we could look at. Determine your best and most profitable customers, the most profitable items or item categories, your customer lifetime value, look at seasonal trends and do some forecasting. You can do some machine learning prediction projects now. So this is the machine learning part that relates more to data science, because machine learning, it's a subset of data science, but it's one of the key components of it. Okay. You can determine which customers are likely to leave your business, and that would go into retention analysis. Like, we would want to try to keep these customers, and we would want to know who these customers are and what probably is the likely thing that indicates a customer would leave our business as a customer. We can look at customer segments. This is a very important project. Recommendation systems, like we've seen with Netflix and Amazon before. We can do some A/B testing of ads and all these things. You can check like UI, logos, that sort of stuff. Fraud detection. And you can do some natural language processing of social media sentiment. So let's look at each project in little detail. So we're looking at our best customers. So many businesses or many people mistakenly think their best customers are the ones who spend the most. Now, usually that's a safe assumption. However, there are some exceptions and some other metrics we can use to find our best and most valuable customers. Look at something like gambling. I've worked in the gambling industry before, and basically customers who deposit the most often are probably the most skilled gamblers. Sometimes, not all the time. Sometimes there are people who just deposit and we keep getting money from them. So they can actually be, these customers who are skilled gamblers, they can be profiting off a business a lot. And this happens a lot in sports betting, because sports betting isn't always by chance. Sometimes people have inside knowledge. Sometimes people actually can be like gaming the system, like bribing players. It's kind of like a big thing sometimes. So it's something we should look at, okay? Also, retailers like Amazon, who have customers who spend hundreds monthly. However, due to their relaxed return policies, these people can be returning products regularly. So these people, while they are big spenders, they're actually returning all the items to Amazon and basically just renting these items for free, because Amazon now has to take back their items, their used items, and probably refurbish them and sell them as B-stock or as used items. So they're losing money on these big spenders. So it's key that we know how we identify our best customers and then find a way to find them using the data. Even outside of profit, actually, you can look at customers who perhaps generate the most referrals, or perhaps continuously increase their spending over time. These are metrics that a good data analyst can track and over time, and maybe even predict who in a year is going to be our best customer. So what about this? Getting the most profitable items and item categories. It's fairly straightforward. However, there are a couple mistakes people can make. All right. For instance, this is a project I actually worked on with someone. They were looking at their items that they sold, and just using a simple SQL query, they thought a certain item was a top seller for years. And I looked at the data, and within an hour, I saw an issue. And the issue was there was a brand of beer that they didn't think was the best seller, but they knew it was a top 20 item. However, that beer was sold in 3 variations. There were cans, medium, and large glass bottles. I think the medium was in cases of 24. That's why it wasn't spotted as a top seller. So this beer actually was their top seller, and they had no idea. It didn't even make the top 10, mainly because I think number 12 or 11 was the first the cans, I believe, of the beer. So that actually shocked them. So additionally, categorizing items can shed some light on what customers really want. So if we categorize all alcohol together, then categorize all our candy together and this kind of stuff, we can actually maybe get better insights into what our customers are buying. Customer lifetime value is actually very important, okay? Because basically you can see in this graph here, we have 3 types of customers. The majority of customers fall in this range here. And then there are some very profitable and non-profitable customers. So you're going to want to know basically who is the the customer value over their lifetime. And it can be a generic formula, or it can be specific to these segments here. So in this case now we actually need to know who are these guys and what their lifetime value would be. So why is this important for? Because if you're spending money to acquire customers, you're going to want, suppose it costs say $100 to get a customer through marketing, but that customer's lifetime value is $80, you're losing money. Or what if you find a method, say it's Google Ads in some part of the world, that was acquiring customers quite cheaply, but those customers turned out to be almost non-profitable or just very low lifetime value customers. Again, you're losing money. And what if there was a way someone told you, hey, we spent $300 to get a customer here, but then you look at stats or the data and see that those type of customers were generating $500 over their lifetime value. That is far more valuable for you to know. So it's good for marketing and customer retention to know these things. And look at seasonal trends. Seasonal trends are actually very important, because understanding the seasonality of your business can affect stocks, getting early stocks, launching promotions early, preparing for other trends as well. You need to know these things. Look at this funny one here. This is when Rihanna's song Umbrella came out. And apparently coincides, the peak of that song coincides with every most rainy day of the month. It's quite funny. And most likely it's probably because radio stations or whatever, or just people in general are singing the song and it gets stuck in someone's head and they want to go down in YouTube when they get home and listen to it. So that's probably what's happening. But things like this, businesses need to think about. And this is an important one. Businesses need to know which customers can leave their business. Retention is an exercise that's often proposed and performed by businesses when they try to prevent their customers from dropping their service and going to a competitor. So imagine that we're trying a retention strategy that involves giving gifts and a personal call to all your customers. But what if you had 10,000 customers? That is going to be an exhaustive waste of time and money. So it would make more sense if we can create a model to predict which customers were most likely going to leave. And what if we actually could even go more granular, look at the customers who are most likely going to leave and see if they're actually those high customer lifetime value customers, and we target those. That way the business spends a lot less time and money retaining those customers, and those customers are the most valuable to the business. And this is another key thing here. Customer segments. So we have all these types of customers who shop at our business. And we need to know basically who are they, essentially, like what metric they belong to, what category I should say. So by performing advanced cluster analysis, we can reveal some very insightful things. Like for instance, the supermarket can have customers who are middle-aged women who may shop during the day, age-retired persons who may shop even earlier in the day, school children who may be coming right after school. So let's go back to that slide. So these are just 3 examples of customers we can have. So if a grocery knows this, they can actually have specific marketing at different hours of the day targeting each group. That way we get more sales from our groups, we know who our customers are, and we can tailor our products and advertising to them. It's much better knowing this. And there are a lot of clustering metrics you can use in data science, and we'll discuss those later in the course. And this is a funny one. Recommendation systems. I mean, they don't actually work like this in real life. This would be hilarious if they did. But this is a very important thing, especially for e-commerce sites that have a large variety of, or quantity I should say, of items. And the reason for that is because you're just spoiled for choice. It's like you go to a site like eBay or Amazon, and you literally have millions of items. How do you even begin to find like what you want? That's basically what recommendation systems do. Basically, they try to find, go back to this, what items are tailored specifically for you to help you shop. It's like having a personal shopper with you. And A/B testing. A/B testing is like critical in the business world now. You need to test different ads, see what's performing better, test different, like, in real life, it's going to be like shopping display windows, that sort of stuff. So we need to know how optimize our business, like look, layouts, all these things, to basically maximize our sales. However, this is not easy. It's not as trivial as people would think. It's not just trying A and seeing how it works for day and trying B. You actually have to design the test. You actually have to have the statistical knowledge to make sense of the results afterward, to know if it wasn't just a random chance B outperformed A, or if it actually B is better. And lastly, fraud detection. Now, businesses lose a lot of money from fraud. I know for a fact that at a gambling company I worked at, there would be like quite a few people attempting to defraud us every so often. And sometimes we never built any AI solution to detect it because we didn't have that many customers at a time, like new customers coming in. However, it would imagine like Bet365 in those companies. They probably have people trying to sign up with like fake passports, fake IDs, fake credit cards, stolen credit cards, I should say. So businesses need to know how to detect these types of frauds. And there's so many others. Besides stolen credit card and identity, there's affiliate fraud and basically tons of others you can do. So if we have machine learning models we can use, we can eliminate fraud. And as you can see here, fraud is $1 billion business and it's growing every year with people becoming more exposed to hacking and more online shopping, it's just larger economies is just going to keep growing. So we need to get better at detecting fraud to help basically save your business. And lastly, I mean, it's not lastly, there's actually a ton of other AI and data science projects you can do. But since I only limited to 10 for this slide, for this section, the last one is going to be natural language processing, NLP stuff. And there are actually tons of NLP projects you can do. It's like, I mean, I didn't even mention it here, but it's like in the investment world and trading, it's like NLP is key. Like you can actually have social media headlines from all over the world being streamed, sentiment, how they correlate to each stock. It's massive. And typical businesses though, you can actually use NLP to like summarize your survey data. So if you give customers, like thousands of customers, a survey, and you basically want to just get some insights quickly, we can use NLP to actually extract that insight. You can actually summarize reviews and testimonials to get some key pointers and know exactly what people are saying. You can build chatbots to basically save on like customer service agents and call centers and that stuff. And you can do social media sentiment to basically see, maybe in a graph, have it plotted, whether our feedback on social media is good right now or bad right now. So these are the 10 projects I would emphasize that every business is probably capable of doing and should be doing right now in this modern day. Thank you. Okay, so now let's look at how deep learning is changing everything. So the power of deep learning. So machine learning has been around for decades, actually, maybe since the 1960s or even before. However, what brought on the recent data science revolution was the increasing computing power that we have now, cheap data storage, highly developed software and tools that made it far more accessible to us programmers now. And basically what happened is that around in 2010, basically typical machine learning was reaching a point where it wasn't getting significantly better. They were just incremental improvements every year, but nothing drastic. However, this is around when deep learning started to take off. And we basically, on some typical popular data sets like the MNIST and CIFAR, those are computer vision projects and those stuff, deep learning decided to destroy like other machine learning methods, significantly so. And from then on to now, it's just been taking over. So anything where deep learning could have benefited, it benefited significantly. So why did deep learning win? Or not, I shouldn't say win. Machine learning is still very popular and still very useful around. But what did it do differently? And basically deep learning was able to learn very complex relationships in non-linear data. And you'll basically learn what non-linear data is later on. But just remember that machine learning wasn't able to do, if there was a complex data set and machine learning was maybe reaching like 70, 80%, 90% accuracy, deep learning could learn that extra bit to push it closer to 100%. So deep learning solved a lot of these problems and ushered in a new revolution. That's how we have all this advanced computer vision, NLP stuff, all these new recommendation systems that are just amazing right now. So yeah, it took our models from, yeah, that's a pretty good model, to, whoa, that's scary good, and that's better than what I can do. So this is what I mentioned here. It's basically, it bested a lot of these benchmarks in these things, and basically it allowed researchers like us to tackle even more difficult problems that we thought were too challenging. So these are some examples, sorry about that cough, of what deep learning can do right now. It can do things like lip reading right now. It's quite cool. The transition quality, look how much like neural networks compared to humans right now in perfect translations, getting quite good. So as we can see, deep learning is gonna be here to stay, and it's gonna keep getting better and better as we evolve and create new training methods, new advanced algorithms. There's actually so much in deep learning that we can do with just general neural networks that allow us to build so many powerful tools. So how does deep learning even work though? So We will go into extensive detail into this later on. I'll have like an hour-long lecture on the inner workings of deep learning. But for now, consider it machine learning on steroids. And yes, deep learning has achieved in many tasks better than human performance, but it came at a price. And that price is slow training time. It sometimes takes weeks for a deep learning algorithm to be trained. And that's on like a lot of heavy GPUs and distributed systems. Also, it needs a lot of data to get really good. So this is why I said machine learning is still very useful, because deep learning, when you have the time and resources to train, when you have the data, especially the amount of data you need to train, it works brilliantly. However, these are things that aren't always accessible to us. So, like I said, deep learning learns complex patterns and relationships, and it's extremely versatile and allows it to be customizable and adaptable to a wide variety of applications. So here's a nice quote by Andrew Ng. Basically, deep learning, data is to deep learning what fuel is to a rocket engine. So basically, that's why we need so much data. But rocket engines are powerful, which means deep learning models are super powerful once we feed them the data. So that's it for our deep learning slides in this section. I hope you enjoyed it, and I hope you took away why it's changing everything and why it's so important, what is its weaknesses, and why basically it's going to change everything in future. Okay? Okay, so now let's look at the roles of data analysts, data engineers, and data scientists. So I promised to talk about this earlier, and now here I will. So let's look at each. So what do data analysts do? Data analysts translate raw numbers into comprehensible reports and insights. As we know, all businesses collect like lots of data and sales figures. However, what data analysts do is basically take this data and basically use it to make better business decisions. And they're often quite good at creating visual illustrations and charts to convey meaning in their data. And they're actually quite good at figuring out like trends in cash flow and how to schedule employees and optimal pricing and more. So these are what analysts do. They don't do machine learning essentially, but what they do is pretty much statistical analysis, and they do a lot of like charts and trends and reports and that sort of stuff. They're quite good at SQL, and sometimes they can be quite good at Python too. So these are important guys, don't forget that. Data engineers, now these are actually very important guys, especially in relatively big companies. These are the guys who basically connect all parts of the data ecosystem within a company and make it accessible to us analysts and scientists. So what they do, basically they access, collect, audit, clean data from various applications and bring it into usable state by building ETL pipelines. They also maintain and choose and create efficient databases for us. They build a lot of data pipelines to take data from one system to the next. They basically manage and monitor all these systems as well to make sure they're scalable, secure. They do a lot of DevOps too when deploying models and that sort of stuff. So actually, I just said it. They deploy our models, and they work in production, a lot of production systems. So they understand a lot of big data concepts too as well. So these guys are very highly paid as well, because these things, a lot of these things, are not easy and require deep knowledge of data and underlying systems and databases. So now this comes to us, the glory boys, I should say, the data scientists, the AI guys. So what do we do exactly? We basically use machine learning and deep learning to build better prediction models. No idea why that came up on top. But basically, let's go back to it. We clean and pre-process a lot of data. Basically, it's called data wrangling from various systems and make it usable for algorithms. We evaluate all the statistical models and results to determine the validity of our analysis and our predictions. We test continuously and improve the accuracy of our models over time, because models do deteriorate over time, and that's because maybe it was trained on one set of data and the data has slightly changed over time. So we always have to keep updating our models. And much like data analysts, data scientists build a lot of data visualizations to summarize the conclusions and basically to convey their analysis and reports to executives and decision makers in the business. So this is the hierarchy of needs, and it's created by Monica Rogati. Basically, this is what data scientists do here. AI, deep learning, ML stuff, A/B testing, experimentation. A lot of it is done here. Now, data analysts. What do these guys do? These guys do analytics, metrics, aggregate features, training data, segments, anomaly detection. All of these things here are actually done by data scientists, but this is what data analysts specialize in. And these are what data engineers do at the bottom here. Build reliable data flow, infrastructure, ETL pipelines, data storage, all these monitoring and stuff. This is what's done here. So this is the hierarchy of needs here. And this is what the categories of it are exactly. So that's it. I hope you understand the difference between these three roles, these three data roles in a modern company. So lastly, to summarize, because this battle and debate is going to go on forever, what's the difference between data analysts and data scientists? Now, the key difference, honestly, is that data scientists can do almost everything data analysts can do. However, data scientists are very good at machine learning and programming, whereas these guys don't need to be either. They can use Excel or SQL, or all these things, and Tableau as well, and they can do a lot of powerful stuff with those tools, by the way. Don't get me wrong. However, they don't know the advanced statistics and modeling that these guys would know. So that's the core differences right there. Thank you. Okay, so now let's take a look at how data scientists approach problems, because there's generally a process flow that we follow for most problems. So let's take a look at it. So this is effectively the data science process right here. This image is not mine. It's taken originally by Hilary Mason and Chris Wiggins, but basically it conceptualizes a lot of what I want to explain here. Data science process. So now what we do first is that we take data, we find it from our data sources, we clean the data, we explore it, find patterns and trends in the underlying statistics, and we model it, do the prediction models, and then we interpret the results. So we can go through each in detail. So in every course, and including mine, you'll be given data sets to work with. However, in the real world, data doesn't come by so easily, and in fact, finding data can be an arduous task, as it can involve generating complex SQL queries where you need to understand how the data was generated carefully, because you can mess things up a lot. We can actually do it ourselves with web scrapers, or even manually build our own data set. Like, it's going to be tedious, but you can actually do this once the data is valid. So once you have the data now, you got to clean it up. So it's been said many times, and it actually is pretty true, 70% of your time as data scientists will be spent on this. Wrangling, munching, pre-processing, feature engineering, call it what you want, but getting your data into a form that can be usable by machine learning algorithms is sometimes quite tedious. And my projects actually don't make it seem that tedious, but in reality, I'll talk about it a bit more. It is. So it's the unglamorous side of data science, but is one of the most important steps. Because you got to get your data ready to be inputted, is that a word even, into your machine learning algorithm in a way that makes sense, okay? Because algorithms take data in a specific format. It has to be cleaned up and processed, and features extracted, features like categorical variables laid out properly. So, it's a lot of data is messy, by the way. Should have mentioned it earlier, but data in the real world is very messy. And even clean data sets, like clean in inverted commas here, is not clean. You'll see why. A lot of our case studies and projects will involve a lot of data wrangling, by the way. So you'll get used to it. So this is actually why a lot of these cloud-based machine learning tools won't actually replace what data scientists actually do, because a lot of what we actually do is this. And this stuff can't easily be done by AI, at least not yet, because you're going to have AI that understands the business domain, understands what data is important, how it was generated. So, maybe one day it can be done. However, it's not easy yet. And this is the exploratory analysis part. And this is where you do a lot of cool visualizations and try to understand like the underlying trends and statistics of the data set. So we call this the exploratory data analysis, or EDA. And it's very helpful. Basically, why is because we can detect patterns, anomalies. Those are like outliers and bad data effectively sometimes. And it's also a good sanity check to make sure data makes sense, because you want to always inspect your data carefully before going ahead. Because sometimes you can have something like where as simple as like wrong currency or like a price before VAT, that type of stuff, it messes with your data a lot. And the modeling part. So modeling data is a part where we actually build our machine learning models. So we use these algorithms here to create a model. So data is usually split into two parts. Our training data set. This is what we use to train our model on. Like our model only sees this data and basically forms the statistical underlying like mathematical equations using the training data set. So this is how we build our model, and then we use our model on the test data set, which is the unseen part of data, and we assess its performance. So this is a critical step right there. We train on one set of data and we test on another to validate its performance. And then we have to interpret the performance. So there's a lot of metrics here. I won't explain this diagram, but I will explain it later on in the course. Basically, we need to know the model's strengths and weaknesses. And we need to have a proper understanding of this, if this model is applicable to the domain we're working in. And if not, or if it is, what can we do to make it better? And we also need to know how to communicate its effectiveness to the people who are using the model. So yeah, basically it goes back to the example I was looking at, like with diseases and stuff. You want to have a model that always gets it right. Always finds a disease. Doesn't always have to get it right, but always has to find the disease. That's the key point. Same with fraud, actually. You want to find the fraud. If you identify fraud and it's not fraud, it's okay. But if there was fraud and you missed it, that's bad. And then the last part here, which wasn't in the diagram initially, but it is an important part, is deploying this data, this model, into production. And this is where data engineers and software engineers come into play. However, in recent times, I've seen a lot of data scientists are basically being asked or being told they have to do this part of the project now. In my case, happened to me too. So you will actually, it's very, very good and useful skill to have to deploy working models into production. Because you're going to have to understand how it scales, how to make it secure, how to make sure that it doesn't crash, how to make it like work fast, all these things. It's quite difficult, but quite fun too as well. Okay. And also we have to actually, once you deploy a model into production and said it's 98% accurate, that's accuracy is on your training, on your test data set. You don't actually know how it's going to perform on new real world data. So you actually have to continuously monitor and assess its performance, because data can change, like patterns can change in the data you use. So you're going to want to do some model evaluation every so often. So like I said before, communication is vital for a data scientist. And here's a famous quote, or basically a thought experiment or survey that was done. Basically, I don't know where I got this from, but I remember reading about it. It basically was asked to a lot of executives in the audience, what was a more important skill for a data scientist? The ability to build sophisticated deep learning models, or the ability to make good PowerPoint slides? And the majority of the audience said the latter, PowerPoint slides. And that is because a lot of people need a data scientist to communicate effectively what their findings actually are. It makes no sense sometimes to have all these amazing models and you're not really communicating what they actually do, how they achieve what they achieve, or what they're good at or bad at. So you're going to be, and what they can do for the business effectively. So you're going to need to know how to communicate properly in the business world to make your data science projects relevant. So that's it for this section, and now we're going to move on to the course part and how you basically use this course to become a complete and basically hireable data scientist right now. So thank you.
Subscribe now and press the bell icon. Never miss an update.